Okay, we want to find the limits of functions when x approach to a certain value. So the first one, we have a rational function. And we see -7 is not in the domain of this function. Because if we plug in -7 for x, -7 plus 7 will be 0. So something dividing by 0 does not exist in mathematics. So what do we do with this? We check it, we observe this, we see, oh, maybe we can simplify it, right? So when we simplify this, and the numerator is a difference of 2 squares. X squared minus 49 is 7 squared. So it can be written as x plus 7 multiplied by x minus 7. Right. Then the denominator will still have, let me see if I can add a limit. If I have a limit sign here, that will make my, oh yes. So limit when x approaches to -7. Right? But my denominator is still x plus 7. Right? Now we see something nice. We have x plus 7 as a factor in the numerator. Then we have x plus 7 in the denominator. So something divides itself, becomes 1. Then this function becomes just x minus 7, right? We still have this limit, carry this limit with us. But the function was simplified to be x minus 7 only, a linear function, right? Polynomial of degree 1. And the -7 indeed is in the domain of this function. We just plug in. We just plug in. So that's -7 minus 7, which is -14. So the limit of this function is -14. Let's see second one. Second one with a sine. So the function is a sine of 7x divided by sine 5x when x approaches to 0. We want to use one of the identities, right? Limit when x approaches to 0, sine of x divided by x equals 1. So you want to use that. But we're missing the angle. The angle is 7x. So we need to multiply 1, and this 1 is 7x divides itself. Now we have, right, this part becomes 1. So limit, we can split this into 2. It's just too much for me to write with my hand on the tripod. So I'm just explaining, right? So product of 2 rational, we can look at this as rationals, right? Rational functions can split into a product of 2 limits. Limit of a product functions can be split into product of limits. So limit of this part, sine of 7x, the angle is 7x, divided by the same angle, 7x, becomes 1. Becomes 1. Then we're left with limit, and also we have sine 5x in the denominator. So sine x divided by x of limit x approaches to 0 equals 1, and also is the inverse approaches to 1. So we need a 5x. We need a 5x in the numerator. So this is 7. We have x already. We just have to multiply by a 5. Okay. We multiply by 5 in the numerator. We multiply 5 in the denominator. We multiply by 1. Right. Now these two give us 5x. So 5x over sine 5x of limit x approaches 0, also 1. So what's left? We have 7 left. We have 5 left. No, we have 7 left in the numerator. We have 5 left in the denominator. A limit of a constant is just a constant. So limit of this one is just 7 over 5. Let's see 3. rational function involves square root function. So limit approach when x approaches infinity. Okay, when we have this kind of questions, we use ignore rule. I call it ignore rule. What does ignore rule mean? Ignore rule means only take the leading term in the numerator, because the numerator rational functions will involve square root. Is the leading term of the numerator and the leading term of the denominator. What denominator is just one term. So square root of 4x squared, that's just 2x, right? So we ignore 25, ignore the lower terms. If you have more terms, we just ignore them. This is the leading term of numerator, leading term of denominator when x approaches the infinity or negative infinity. We'll apply ignore rule. So 2x over 5x, x cancel with x, so that's just 2 over 5. 2 over 5. That's for this question. Let's see 4. So this is a famous difference of quotient, right? Difference of quotient. H approaches 0, we have this. So with this kind of questions, of course, 0 is not in the domain of this, because if we substitute 0 into H, we get 0 in the denominator. No, we cannot do that. So what do? We use the difference of two squares again, right? We multiply here, we have something minus something else. You can think as A minus B form. We want to multiply A plus B form. Then we get A squared minus B squared. Difference of two squares. Very useful. So I have square root of x plus h plus square root of x. You'll see why we want to do this. And of course, the denominator has to be the same, right? So I'm not going to write it. So denominator is also square root of x plus h plus square root of x. So when those two multiply, we have a squared minus b squared. So this numerator becomes square root of x plus h squared becomes x plus h. Minus square root of x squared is just x. X minus x cancel out. So this whole thing becomes h. Then we have h multiply this denominator. Remember that this denominator is square root of x plus h plus square root of x. But the phenomena is this. We see we have h in the numerator, h in the denominator, they cancel to be 1. H divided by h cancel to be 1. So this becomes the limit of 1 over this term. Square root of x plus h plus square root of x. Square root of x plus h. Sorry, it was very difficult for me to write this. I probably need to use my iPad to do this. Okay, now we check to see if 0 is in the domain of the new function. Yes, we plug in x into 0. We plug in x into 0. We plug h to be 0. No problem, right? So we get a 1 over square root of x plus square root of x. That's 1 over 2 square root of x. That's it. That's the limit for this one. Okay. Limit h approaches 0, the difference of quotient. So it's 1 over 2 radical x. It's a function in terms of x. Oh, let's see, this one involves sign. So let's check to see if pi is in the domain of this function. Sine function domain is all real numbers. So pi is in the domain. So we just plug in. Let's just plug in, right? Plug in, we got a sine pi, sine pi. I'm going to use pi, representing pi, sine pi, right? Well, remember the sum of two, right? Sine pi, so what's sine pi? Sine pi is 0. So this becomes the sine pi, or sine pi again, 0. So limit of this, limit of 5 is just 0. Let's say 6. So first we want to check if 0 is in the domain of this function. Indeed, if we plug in 0, this term becomes 0, but we still have 5 in the denominator. So we just plug in, right? So the numerator we get 4 times 0 is 0, cosine 0 is 1, 1 squared is 1, and the denominator is 5. So we get a 1 over 5. That's for 6. Let's see 7. Again, x approach to infinity. We apply ignore rule. It says ignore the lower terms in the numerator, ignore the lower terms in the denominator. We take the leading term in the numerator, we take the leading term in the denominator. X squared over x squared becomes 1. So the limit of this one is 3 over 5. So what is the principle behind this ignore rule? Basically, we divide by x squared for every term. We divide by x squared in the numerator for every term. For 3 terms, we divide x squared in the denominator, right? Then we see this term divided by 3x squared, it becomes 3, become constant. This divided by x squared becomes 1 over x. Then when x approaches infinity, 1 over x approaches 0. Same thing for 2. 2 divided by x squared, when x approaches infinity, 2 divided by infinity, so that means it approaches 0. So that's the mathematical principle behind the ignore rule.